Hello everyone. In this video on dimensioning and for drafting in general, I wanted to emphasize the important dimensioning rules. I collected a bunch of them more complete than my longer video on drafting in SolidWorks or on CATIA in CATIA, and then I wanted to go over them and explain them because I have collected a bunch of them here and I wanted to tell you exactly what to do so when you add dimensions, they are basically according to standards. So the first thing is never put dimensions and leave dimensions inside the view. Everything should be outside, right? So if I go here and add this dimension, and then I leave it here inside that view, that is the first red flag for somebody who's going to check your drafting and say, hey, this person forgot to bring this guy out. Okay, so never leave anything inside. Number one. Number two, if you have dimensions, don't go ahead and try to distribute the dimensions evenly among the views. Let's say here, this part has what? It has three major dimensions, right? Length, width, and height. And you might say, well, I have three views, and so I'm going to add the depth to this view, I'm going to add the length to this view, and I'm going to add the height to this other view. Well, this is not typically a good idea when you're doing what? Drafting. Because most of the time, out of your three views, you can say always, but in simple cases, definitely, one of the views is redundant. Using the two other views, you can easily imagine the 3D shape of the object and all of the details. And the third view can easily be eliminated. Just like in this case, this third view is literally redundant. So if I want to distribute the dimensions, I'm not going to put anything on this right view because I can easily just get rid of this part. So I would add that height instead to my front view. Okay, so don't go ahead and I have three dimensions, three views, each one gets one. No, that's not how you typically do it. You try to concentrate the dimensions on one or two views most of the time, because as I said, mostly one view is typically redundant. The next thing is you never show 90-degree angles, okay? If I have a 90-degree angle, I'm not going to show, hey, by the way, did you know this angle is 90 degrees? Well, unless a degree is specified, unless an angle is specified, then if it's not specified, then you say it's 90 degrees, okay? So unless I say, hey, look, this angle here is, for example, 135. You do that, you specify that if you have to, although in this case it's a chamfer, you don't do it that way, but yes, this is not 90 degrees, so I specify that. This one is not 90 degrees, I might specify that, but this one is 90 degrees, it's just inferred. The next thing is the dimension lines should never cross. So here, let's say I have this dimension, then I go ahead and I add, let's say, a diameter to this guy. And I do it like that. Okay, do I have an error here? Yes. Here, as you can see, this leader, which is a dimension line, and this double arrow, they have crossed at this point. That is not acceptable. You should always make sure that your dimension lines do not cross each other, okay? Separate them. Now, you might say, well, let's say here, for a moment, let me just go ahead and add some dimensions here. So if I add this dimension here, and then if I add this dimension here, right, can I have something like this? Is this okay or not? Because again, I have intersection here. But what is intersecting what here? Your dimension line is intersecting an extension line for 118. So can a dimension line and an extension line intersect? Well, we try our very best not for this to happen. We don't want even a dimension and an extension line to cross each other. Okay, and there are ways to do it, which is one of our next topics, is in a stack method, which is this guy here. So I'm showing you the offsets of this edge here and the bottom edge both from the top edge. So this is called the stack method. In the stack method, if you don't want this to happen, you bring smaller dimensions closer to the object and longer dimensions further away, and this way nothing is going to intersect. Okay, so this is one way in stack dimensioning. But if it happens, there are some scenarios where it's too crowded and there are too many dimension lines and it's very hard to get it. Is that a fundamental mistake? No. It's not like two dimension lines are crossing each other. If an extension crosses another extension or an extension crosses another dimension, it's not as fatal, but we try to avoid it the best that we can. We try to avoid all intersections, but dimension and dimension is absolutely prohibited. Okay, so keep that in mind. So I already explained that in stack method, you want to keep smaller dimensions closer. Okay, so I explained that one as well. The other thing is only dimension everything once and in the view that you can see it better. Do not use redundancies. If you have to use reference dimensions, and you don't do it all the time. I explained reference dimension in one of my previous videos, but let me explain that one more time. So, for example, that's one of the mistakes. Here I have provided the length of the object, then I go in the top view, and then I do it again here. Well, that's absolute redundancy, okay? You do not want to do such a thing. You do not want to do such a thing. Only once. Now, the other thing is if you have symmetry in your part, then you do not want to show both sides of the symmetry, only show one side. So let's say, just for the moment, this part is not symmetric, but if I had some symmetry here, right? So I had a symmetry line between this top and the bottom, right? If I provided some offset, so let's say here I go to a sketch and then I draw a circle here, then I draw another circle, let's say here, right? And let's say these are at the same offset and this part is symmetric. If I provide this offset for you, I'm not going to do this other one as well. Okay? So here, for the sake of being accurate, let me make it 1.5 for both of them. Okay, that's the meaning of symmetry. If I have symmetry, I have one number on one side of the symmetry line. I'm not going to put the number on the other side. Just one of them is enough. If it's multiple feature, I use n times, or I say typical, as I mentioned in one of my earlier videos. You're not going to show both sides. That's the advantage. That's the thing that you use for symmetry. You should not repeat that, okay? So that's a redundancy here. The other thing I want to say is sometimes you add some dimension, like for example, what? Let's say here I add a dimension to this chamfer, okay? And let's say I say, for example, this chamfer from here to here is 118, right? Now, should I provide this dimension as well? Well, clearly not. Why? Because sum of these two is 5.66. So if I have this one and if I have this one, this is clearly should not be there. And that's one of our chain rule, which we're going to talk about. So I should not really put this or this. One of these two is redundant. Okay? If I have to use redundancy because I don't want the technician to do math and use calculators and everything, and I just want to show them for a reference, then I click on that dimension and then I add parentheses around it and say, hey, this is a reference dimension just for your own knowledge, for your own information. So you don't use calculator and subtract them. I know I should not leave it there, okay? So make sure you do not have redundancies, okay? And that's how you use the reference dimension. The other thing that I mentioned very importantly is show the dimensions where you can see that thing. For example, here, look, you have a chamfer. And this chamfer can be seen as a surface here, as a surface here, as in the edge here. In which view would you show the dimensions for this chamfer? Well, you might say, I go ahead and show the chamfer dimensions, one of them on this right view and the other one on what? On this top view, like that. So these two, 118 and 118, these are my chamfer dimensions. Well, for several reasons, this is not a good idea. Why? First of all, you are distributing the dimensions on several views instead of focusing everything in one place as much as possible. The second time, in which one of these three views you can see that profile of the chamfer? Well, in this view. So if I want to show those dimensions, I better put both of these on what? On this view instead of just distributing them equally among those two other views. In this view, I can see everything better. So if I have to, I go ahead and what? I go ahead and show one horizontal here and one vertical here. Now, in this case, it's a chamfer. You should not even do it this way. It's not an inclined surface. Since it's a chamfer, actually, you need to use the chamfer rule. And for that, you go here and use the chamfer dimension and then provide a chamfer like that with a single leader. Okay, so if I want to show my chamfer dimensions, I would show it in this view that I can see better. Or let's say for the moment, let's go ahead and add a fillet radius here, right? So if I want to add dimensions for that fillet radius, the question is, where do I add that? So here I go ahead and add some fillet, and I guess 10 mil is good to go. Let's see. Yes. Save. Get out. Go back and update. Yeah, it is updated already. So you see, I can see the fillet here as a surface. I can see it as invisible here, and I can see the curve here. Where would you show it? Well, definitely here, because you can see the profile. So you only show the stuff where what? You can see them better. That's the best way to show a dimension. Okay? Now, let's talk about the chain method. As I said, in the chain method, which is each feature measured from the previous feature, you want to leave the last part of the chain off and instead show the whole dimension of the chain. And the reason for that is the tolerances will add up. I explained that in one of my previous videos, but I can briefly explain this again. So here, you see I'm doing chain dimensioning. So each wall is measured from the previous wall. So 50, 79, 59, not everything from the left side. So this is called the chain method. And instead of me showing this last part of the chain shown by this arrow, I show the total length of the chain. And the reason is that the tolerances will add up. So if, let's say, the tolerance on all of the dimensions in this drafting is 0.01, 1/100. So if the machinist make this guy with the maximum size that I'm allowing, so 0.01 extra, so make it 0.51. Make this guy 0.80, make this one 0.60, and this one, whatever it is, it makes it an extra 0.1, right? So at this moment, how much is it? This is 138, 188. From this one, it is 37. So instead of 0.37, they make it 0.38, right? So I make each one of these because I'm allowing an extra 0.01 on each one. The manufacturer makes each one of them 0.01 extra length. Well, what would happen to the total length? Yes, because each one of them is made 0.01 bigger. Now this guy is going to be whatever I intended, the nominal dimension, plus 0.04 instead of 0.01. So you see, this guy will be what? Will be out of the tolerance because I only allowed 0.01 for every dimension here. So all of those 0.01, 0.01s are added together. So we say tolerances add up in the chain method, not in the stack method, because everything is measured from the same base, not from the previous base. So if I make this 0.1, there is no reason I necessarily make this 2.01 and this one 3.01, okay? And they're not added together, but here they are added together. So in order to control this total length and keep it within the limits, I show the total length and I leave this last part off. So if I made this one 0.01 extra, 0.01 extra, 0.01 extra, to keep this guy within 0.01 plus minus, then this guy has to be whatever it is, which is 0.37 minus 0.02. I have to make this 0.02 smaller so I can what? I can keep the whole length within tolerances. Okay, so I'm getting some dimensions, no dimensions here, so it gives me some chance to keep this guy under the control. So in chain method, you always leave what? Last part of the chain off, and that's what I showed you here, right? Look, here I have showed you this dimension, right? Or let me do it on this side here. If I want to show these dimensions, this is one part of the chain I show. And then instead of me showing this part of the chain, because here my chain only has two parts, these two, what I would do, I'm not going to show this. Instead, I'm going to show the total length. So I leave this portion off. So if this is made too big, this one, I make it a little bit smaller. So the total length is still within tolerances. I never add this portion here. I leave the last part of the chain off. Okay, so that is about the chain rule and the chain dimensioning, I'm sorry. Okay, the other thing is, let me talk about 9 and 10 first, then go to 8. So do not dimension mid-air. That is something interesting that, let's say here, I want to provide dimensions for this part. So instead of me giving dimensions to basically this endpoint here, right, or this flat surface or anything, I basically virtually extend these lines to intersect and then provide the offset of that intersection point to what? To this edge. Well, this dimension here does not physically exist, right? Why? Because this point does not physically exist. I'm dimensioning this point, this edge, from somewhere that is in the mid-air. It does not, this point physically exist. So this is not a good idea. Only use reference points, the end points for any dimension line that they have physical existence. If they are virtual points, never ever use them. The next rule is do not use angle dimensions specifically in large parts. You might say, why? Well, look here. So here, instead of me providing the dimensions for this inclined surface with, let's say, the rise and run, which is one side is 10, the other side is the difference between 7.77 and 2, I'm showing it with 10, and then instead of this total height here, I'm going to show the angle 30 degrees, right? Well, the problem is this. If the manufacturer is going to make this part for me, it makes it, instead of 30 degrees, makes it 30.5 degrees. So only half a degree error in the angle. Guess how much this tip point here will move? Well, because this is 10, it's not a small dimension, going from 30 to 30.5 makes this end point to be up by about 1/8 of an inch. Right? And maybe that is way too much for my application. Maybe this endpoint can only change maybe 0.01 of an inch or something. 1/8 of an inch is such a big thing, right? Because this angle over this large distance will cause a big deviation. So if I want to put tolerance, I would put tolerance on this linear dimension, say this 7.77 can only go to 7.78 and maybe 7.76, 0.01 plus minus, right? But I'm not going to say it's 30 degrees plus minus 0.5 degrees, okay? Because that causes this endpoint to change considerably. So most of the time, linear dimensions are easier to measure, are easier to control, as opposed to angular dimensions, right? You can always hit much, much tighter tolerances with linear dimensions, but measuring angular dimensions and going into tight tolerances for angles is not as easy, okay? So most of the devices, you cannot go below 1 degree. You need very, very accurate devices in machining to be able to have tolerances for angles that are only fractions of a degree, very small fractions. but fractions of inches are very common. So in general, angles in large dimensions are not the best idea. The next thing is try to avoid putting dimensions on hidden lines. Try to avoid putting dimensions on hidden lines, and section views and other methods can help you. Let me show you the example here. So let's say here, I want to show the depth of what? This circular hole. Now, in my previous video in SolidWorks, when I talked about the hole callouts command, which is here under annotation, I explained exactly what this guy does. But if I want to show the depth of that hole, it's not necessarily a good idea to what? To go ahead and show that depth over here. So I go ahead and say, hey, this is the depth of this hole, like that. Okay, why? Because I'm showing it on the hidden lines. So if I want to provide that dimension here, I can either add it to this diameter directly and go ahead here and add my depth symbol and then provide that 1.57, right? That's one way to do it. The other way is to use this hole callout command, which generates all of that in one single command instead of manually modifying it. So I click on this and click on that, and that gives me both of them, right? Which is a beautiful command. Or the other thing I can do is, instead of that, what I can do is to create a section view, right? So I can go ahead to drawing, go to a section view and cut it right here and bring it out to, let's say, this side, right? Let me move this right view out of the way. And then what? And then all I need to do is, you see now that hole is visible line here. So if I want to show it, I would show it over here. You see? So it's important that you show the dimensions on visible lines. Either here that the hole appears as a circle or in a section view. That's one of the applications of a section view. Do not show dimensions on hidden lines. Okay, what else? For curved surfaces, show the dimensions of the center, not on the points on the curved edge. What does that mean? Well, I've seen in a lot of my students' work that when they want to provide the location of the circle, instead of providing the location of the center with respect to fixed references, so here you see I'm providing the location of what? Center with respect to this edge and this edge, correct? Actually, this one should be with respect to this left side. Instead of providing that, so you see everything is about center, they go ahead and add the dimension from this corner point here to that edge, not from the center to that edge. Or let's say they provide the dimension from this bottom point to this edge instead of center. So never dimension anything on the circumference of the hole. Always locate the center of the hole. Okay, if you have a dimension that is from here, right? So your dimension line is like from here to this. That is absolutely not a good idea, because anybody who wants to drill, they find the center, not a point on the side of the hole. Okay, that is a big mistake, and I have seen it a bunch. The next thing is use diameter for a full circle, complete circle, and radius for an arc. Not the other way around. That's another big problem that I have seen a lot. So some people come here and instead of this is an arc, they go ahead and show this as a diameter instead of radius. So they right click and then say what? They display it as a diameter. So let's say here, if I have that option, you see here, if you go to display option and say displayed as diameter, that is a big mistake. You never show the radius of an arc in diameter. You always show it as a radius. And the exact opposite of that, instead of showing me the diameter of this full circle, some people go ahead and right click and say what? They show it as radius, right? So you can do that, But is that a good idea? The answer is what? No. So you never want to show something like that. The radius of that hole is 2.2. It's the diameter. Okay? So be very careful about that. The next thing is, if you have a circle or a cylinder, a cylindrical surface, where would you show diameter? Let me show you here. So if you look at this picture, I have two cylindrical surfaces. One is this extrusion with diameter 1.5. The other one is this cylindrical hole with diameter 1. You see that I have shown diameter 1 in the top view and then diameter 1.5 in the front view. Well, couldn't I put both of them in one view? The answer is no. So what is the rule here? The rule is this. If it's a solid cylinder, an extrusion, a solid cylinder, you show the diameter where it appears as a rectangle. You show it on the side view. If it's a hole, you show the diameter on what? On the circle. Why? Because if I show that phi of 1 here, then I have to do it on the invisible lines. And I don't want to put dimensions on invisible lines. So I should put that phi over there and this 1.5 on here. So holes diameter on the circles, extrusion solid cylinders, diameter on the rectangular view. Okay, that's another important rule there. The next thing is patterns. If you have a pattern, you want to provide the offsets, not the offset between the patterns, not the offset between one part and the rest of the edges. So what does that mean? Well, let me show you that one. So if you look here, this is a part I have and it has 4 circular holes. And now if you see, the dimensions I have provided are what? The offset between this one and this one horizontal, and the offset between this one and this one vertical. Okay? Yes? And then since this part is symmetric, I have also provided the offsets of what? Of one of these holes, or maybe 2 of them, doesn't matter, from the center. It has 2 center lines, and I have provided this 0.6 and 1.1. So you might say, can I instead provide the locations of these holes from the sides? So here I provide the offset of the center of this hole from the right edge, and then provide the offset of this hole from the left edge, instead of what? And then the entire dimension. Is that a good idea, or is that better to provide what? Instead of those numbers, or one of them, because in this case they are symmetric, if instead of this number, should I provide that one? So which one is good? If I show the total dimension, which is missing in this case, if I show the total dimension, should I provide this offset here or that number 2.2? And the answer is what? This 2.2 and that 1.2. Why? Because if the person or the machine is not drilling it exactly in place and does a little bit offset on the left because the part is not set up properly, so it has some bias. So if the person is going to machine this hole a little bit to the left and then consistently does the same thing for these other 4 holes and basically drill them all a little bit to the left, then because the machine kept this dimension right and there is a tolerance on this 2.2, guess what? These holes are drilled a little bit, all of them off to the left, but this pattern is intact, so I'm still able to use this part, put it on another part with this pattern, and then put the bolts through the holes and attach them together. Although maybe the position of this part on that bottom part is not perfectly as it used to be, but I'm still probably able to use it with a little bit, what? Displacement. So it's better to provide pattern offsets, not the location of individual components of the pattern from other edges. It allows for the part most of the time to be used, even if there are imperfections. What else? On an isometric view, please and please and please, if you ever include an isometric view, do not show anything. No dimension, no hidden line, no center line, no nothing. Okay, so if I go here and I go ahead and add an isometric view, that's one of the mistakes many of my students make. They go ahead and add these hidden lines. Okay, you never want to do that. Absolutely, you never want to do that. Okay, or they might add center line, or they add dimensions here. Hey, I want to add this dimension. What is this dimension? Right? Absolutely do not do that. That's a very, very bad idea. So on an isometric, you are not going to show anything, not even hidden lines, not center lines, nothing. An isometric view is a redundant, non-standard view just for the sake of visualization. Most of the people do not even include this guy. Most of the people do not even include this guy. They just get rid of it. Okay, the same thing goes. I just remembered I need to add one thing for you, and that is do not show hidden lines on the section views. That's another big thing I have seen the students do, is they activate the hidden lines on the major 3 views, but they also add it to a section view. You never add you never add hidden lines on a section view. So in this case, I have cut the part and I'm looking on the left. Now, if I go ahead and switch the direction of the view and look on the right, well, you see, no problem, but guess what? This guy has hidden lines. So actually, if I want, on this guy, I should be able to apply the hidden lines. Look at that. So should I show those hidden lines on this part? Absolutely not. If I want to show that feature, I can do another section at that location. So on a section view, you never show hidden lines. The goal of section view is to see everything as visible lines. Okay, so do not show anything behind the section plane. Do not show it. We never show hidden lines on section views. That's not a good idea. Okay, that's the whole purpose of section view, is to get rid of hidden lines. Okay, if you want to see other features, we add more of them. So that's not a good idea. Finally, for an assembly, if your assembly has n components, you need at least n plus 1 drafting. 1 for the assembly and then 1 per component. Right? So if I have 4 components in my assembly, I need 4 drafting, 1 per each, and then I need 1 for the entire assembly. So I need at least what? 5 drafting. Now this is not really a dimensioning rule, it's a drawing, so I can combine it with 17 with 18 to make it something meaningful. So now in the assembly drawing, you are not going to show dimensions. You are not going to show dimensions. You identify the components with balloons, and if you show a dimension, that should be a dimension that is created during the assembly, not dimension of the individual components. So first of all, as I said, this is, let's say, the isometric view of what? Of the assembly. So on this isometric view, you are going to add what? Balloons, and give names to your components. Okay, and then I'm not going to show dimensions for any of these individual parts. In their own drafting, for the drafting here, for this bearing, for this conrod, for the pin, for the piston, for those individual drafting, I'm going to show the dimensions for each part. If there is any dimension that I have to add on the 3 views of the whole assembly, that should be a dimension that I need for the assembly. Like what? And the example I provided is here. So if you look at here, you see this pin. If you look at the pin, the front of this pin is not flush with basically the very lowest points of this circular hole, right? As you can see here, we have our pin here to hold it in place. And so there is some gap, and there is no flush or tangency or anything here. So how much offset do I need here? How far should I push the pin in, right? How much offset do I need over there? That could be a dimension that you want to add to your assembly drafting. Okay, because you need that for assembly. How far do I push the pin in? What offset do I leave behind? That is the type of dimension you add into an assembly, not individual dimensions. Okay, so I explained to you like 16, 17 rules, important rules that you want to have and consider when you're adding dimensions to your drafting. Hopefully the video is useful to you, and I'll see you in my next lecture. Thank you.